Hi guys. Okay, so today we will be learning through here. I did the videos of these notes that you can help you so that I can help you and not waste a day. And I do expect every single one of you to like listen to these notes. And if you don't have a cell phone, then you better ask someone. And those of you that do have a cell phone or a Chromebook, lend it to someone else who doesn't have anything. So I will leave these notes on the board. So today we're going to be learning about direct variation. What is direct variation? So the simplest thing I can say is that direct variation are proportions and they look like y equals kx, where k is just whatever your y value is over your x value. Okay? So I know this seems a little bit confusing, so just bear with me. You will see an example right now. So let's take a look at this. A recycling center buys glass bottles. When Sandy brought 85 pounds of bottles to the center, they paid her $6.80. Which equation represents the direct variation function that describes y, the amount paid by the recycling center for x pounds? Okay, so they want you to find an equation given this information. Now, direct variation doesn't have y-intercept. It never does. So if anytime they ask you about like which of these could be a direct variation, always eliminate the equations that have y-intercepts. So really, take a look at it. They just want you to find k. So how do you find k? Well, k, remember, I'll write it, equals y over x. So what is my y value and what is my x value? So y describes the amount paid. So how much did they pay? $6.80. X describes x pounds. How many pounds? 85. So that's really all I'm going to be doing. I'm going to be doing 680 divided by 85. Once I input this into the calculator, I get 0.08. And that right there is my k. Now remember, the equation is y equals kx. So that means it'll be y equals 0.08x. And by the looks of this, it seems like my answer will be B. Okay, I scratched. This is 5.9, this is 12.5. Do not be fooled, be careful. It has to be the exact measure. Okay, now let's take a look at the next problem. It says, Paula drives at a constant rate. The table below shows how far she can travel when driving different number of hours. Which equation shows the distance Paula drives d after t hours? Okay, again, you notice that there are no y-intercepts. That's because this is a direct variation. So this is a dv problem. So what are you going to do? You need to find what the k is. Now, remember, the equation should look something like y equals kx. And what is k again? Say it. What is k? K is just a y value over the x value. So take a look at the table. Which of these do you think are easy numbers that you can divide? I'm thinking these. Right? Now, x and y. Which one's your x? Which is your y? Well, this is a table, so that just means that these are my x values and these are my y values. So I literally just put, so remember the y is 100 and the x is 2. So that means that k equals, my y value was 100 divided by my x value, which is 2. And 100 divided by 2 is 50. So that means my equation has to have a 50 in it. So let's see if we can eliminate anything. Well, this one has a 25, so that's not it. This one has a 12.5, that's not it. Which one can I eliminate? C, because even though it has a 50, it's not 50. My answer can only then be B. Okay? Remember, once you have the k value, you can write the equation y equals 50x. Okay? Okay, so for the next problem, this one's tricky because there are no numbers, so you have to read the words. Janet can make 2 dozen brownies for each cup of sugar she has. Which equation can be used to find B, the total number of brownies Janet can make with C cups of sugar? Now take a look at the equations. B equals 2C. Would you agree that this resembles y equals kx? That means that my b's are my y values and my c's are my x values. Knowing that, all I want to do is just find k. So remember, k equals y over x. But in this case, y's are my b's and x's are my c's. So if we take a look at the problem, we need to find what's our b. Our b is the number of total brownies. How many brownies can she make? She can make 2 dozens. A dozen is 12, so that means 2 dozens has to be 2 times 12. So 2 times 12 is 24. Okay, and C stands for the cups of sugar. I don't remember how many cups of sugar she can do. She can, for each, that just means 1. So I'm literally just going to be dividing 24 by 1. And 24 divided by 1 is 24. So that means my answer has to have a 24 in it, and it'll just be 24, x. So which of these matches that? It has to be not A, not B. Oh, and you could have automatically eliminated C because it has a y-intercept. So the answer is C. Okay, so now I'm going to go a little bit faster just because you already know what K is. So you know how to find K. So to summarize, let's see. K equals y over x. So this one says the number of calories we take in varies directly with the amount of food we eat. The function y equals kx describes the y, the number of calories. So y is for the number of calories, and x is the ounces of food. For raw carrots, the constant variation is 0.4. How many calories are in 15 ounces of raw carrots? Okay. Well, actually, I just realized that this problem is actually harder than the other ones because they tell you the constant of variation. This word is important because that means K. So they give you the constant of variation. So here, what we need to do is we need to set up an equation. K is a constant of variation, and here it was set to be 0.4. And they also give us, they want to know how many calories are in 15 ounces. So we're looking for calories. Calories is my y, and 15 ounces, that's my x value because x stands for ounces. So all you would need to do is solve for y. How do you solve for that? Multiply by 15 on both sides. So you better know how to do this. 15 on both sides. So this cancels out, and I am left with 15 times 0.4, and that is 6. So how many calories are in 15 ounces of raw carrots? It would be 6. Okay, for this next one, look at them. Look at what's given. They just give you the equation, so they just want you to find K. Again, what did I say K was? K equals y over x. So literally, just plug in the numbers. It'll be 248 over 64. I'm going to do that on my calculator. 248 divided by 64. I get 3.875. Now, I don't see that on my answer choices, but I do see some things. I can eliminate one answer choice. Which one has a y-intercept? D. So that I eliminate. Now, this is 3.85. Which other one can it be? Well, it can't be 64. So I am just left with 8 over 31 or 31 over 8. So I'm actually going to do it on the calculator, and 8 divided by 31 is 0.258. So this is 0.258. And then 31 divided by 8 is 3.875. So what do you think is going to be my answer? C. Okay, the following problem is even easier. This is what you know. These are the proportions. So during his last basketball game, Matthew made 3 free throws out of 5 attempts. At this rate, how many free throws should he expect to make out of the next 25 attempts? So really, we had to set up what are the two things that they're talking about. They are talking about free throws and attempts. So I'm going to put FT for free throws and attempts for the bottom one. You could be backwards. It really doesn't matter. So he did 3 free throws over 5 attempts. They want to make a prediction. How many free throws? So that's what we don't know. So this is like the missing. I'll put FT for free throws. Can he expect to make out of the next 25 attempts? Okay. So I need to solve for this. This is what I'm solving for. So this can be any letter. It can be like your variable x. Okay. So how do you solve for this? Well, you need to multiply by 25 on both sides so that you can cancel out the 25. And that cancels. And on this side, I have to multiply by 25. Okay? So literally just put this in the calculator. Put this in the calculator, and I'm going to type it in right now. So 25 times 3/5 gives me 15. So this is 15 equals x. So do I see that? Yes, I do. My answer is 15. I'll be honest with you guys, on the STAR test, all the questions that I've seen on direct variation are like number 7. None of 1 through 6, but I am afraid that they will give it this year, because if they haven't given it, then it's most likely that they will give it, sometime, some year. Okay, so turn the page, and now let's take a look at the back. The back, I think, should be easier. I know there's not multiple choice, but it should be easier. So let's see what we get. Which equation represents a direct variation between x and y? So direct variation, I said, has to look like something like y equals kx. So it does not have a y-intercept. So this over here does not exist. So literally, you have to see a y, and you have to see an x, and nothing else. So let's see what we can eliminate. Well, D is out of the question because of this. So that's wrong. Now, B, I see an x and a y, and that's okay, but I see this 5 by itself. That's part of the y-intercept, so that's wrong. And C, 2x plus 3y is fine, but then I see 8, and that is wrong. So C is off, and my only answer would be A, because I see a y and an x and nothing else. Now, there will be some instances where you might see something like this, like 3x plus 2y equals 0. And they're going to ask you, is this a direct variation? And the answer is, well, yes, you see an x and a y and nothing else. The 0 means there's no y-intercept, so that would be the case. So to summarize, a direct variation just does not have a y-intercept. It has to be y equals kx. 13. This one's easy. N varies directly as p, and n is 48 and p is 42. So literally they tell you there the information you need. So I just make a fraction, n over p, and n is 48 over 32. They want you to find p, so p is the one at the bottom when n is 60. Okay? Now, guys, I'll be completely honest with you. This is hard. Well, it's hard because the p's at the bottom. So if you remember anything from 8th grade, it should be you do the cross multiplication. So this would be something like this. Cross multiply and cross multiply. So I get 48p equals 60 times 32. I'm going to do it for you. It's 1,920. And then how would you solve for p? You would divide by 48. So p equals 40. So I think my answer is this one. Now, when do we use situations? When do we use direct variation? I mean, we used a direct variation in situations where as one variable increases, the other variable increases as well. The same can be said about the opposite. If the variable decreases, oops, that's too big. If the variable decreases, then the other variable also decreases. Okay. Okay, the last three. The sales at a baseball game vary directly with the number of people attending. If the sales for a game are 12,800 people attend, determine how many people attend if the sales for the game are 15,000. Okay, so we had to talk about the two things that they tell us. So the two things are sales over people. So how much was the first sale? Well, it was 12,000 over 800 people. And you had to set that equal to the other information. They want to know what are the sales. No, how many people attend if the sales are 15,000. Well, sales were on top, so that means I'm going to write 15,000 over, I don't know how many people, so I'm going to put X. So after this, all I have to do is just cross multiply. So how do I cross multiply? So again, I would just do this, cross multiplication, and this. So my new equation becomes 12,000x equals 800 times 15,000. So let me do that. 800 times 15,000 is, whoa, a huge number. Okay, so that means it's going to be, let me write it over here. Let me zoom in. It's going to be, because it's a really big number, 12,000x equals, I think this is 1, 2, 3, 4, 5, 6. It's a huge number, 12 million. So how do you solve for x? You would just divide everything by 12,000. That's a 2. Let me zoom in. Let's see, let me erase this. So all of this cancels out, and I'm just left with x. You can do this on the calculator, or you can just cancel out the zeros. That cancels, that cancels, that cancels. The 12 cancels, and it's just 1. That was messy. You probably don't have no idea what I just did. Just put it on the calculator, and it equals 1,000. So that would be my answer. Okay. Okay, so now, this is how you would quickly set them up. So just what are the two things that they're talking about? So ounce of medication varies directly with weight of the patient. They're talking about weight. and ounces. So I'm gonna set up that proportion. Weight and ounces. So if a 120 pound adult requires 3/4 of an ounce, so that means a 120 pound person requires 3/4. Now I don't want to write 3/4. I probably do that as a decimal. That would be 0.75. How many ounces are required for a 200 pound adult? Well, 200 pounds, that was the weight that goes on top, and we want to find the ounces. So we cross multiply. So that leaves me with 120x equals 200 times 0.75. So let me do that on the calculator, and that is 150. To solve for x, I just divide by 120, divide by 120. X equals 1.25. So 1.25 ounces would need this 200 pound person. Okay. And last but not least, let's see if we can figure out the two things that they're talking about. So just by scamming through it, varies directly with the number of minutes in the shower and gallons of water. Okay. So, but actually they don't even want you to find anything else. They just want you to find the constant of variation. That is your K. So the constant of variation is the K. So again, let's see if you remember. How do you find K? That's just Y over X. So now how do you know which one is Y and how do we know which one is X? This one tells you the gallon of water used to take a shower varies directly with the number of minutes in the shower. So this right here, oops, sorry. Let me go back. Oh. This right here, gallons of water, is the first thing, and that's my Y. Think about it as like Y equals MX plus B. Y comes first, and then number of minutes is going to be my X. So my constant of variation is my Y stands for gallons over minutes. So how many gallons did we use? 48. Over how many minutes? 8. And that is 6. So that means my constant of variation, K equals 6. Is that? Okay, so I know this was like 20 minutes notes. I tried to be in depth, and you have the videos to follow along. I thought this was a very easy assignment, so do turn in the homework. It will be due, it should be due today in class because it was a very easy homework. It's 20 minutes of notes and then 20 minutes of working on the homework, and you should finish much, much faster than this. Okay? Thank you guys. See you tomorrow.